I'm Bob Webster, and my lab is the Med Lab. It stands for Medical Engineering and Discovery Laboratory. We try and make medicine better. We work with doctors and we apply engineering to make medicine better, and it's really that general. We work on all different organ systems in the body. We have projects for brain surgery. We have projects for going through the nose to do surgery in the sinuses. We have projects in the throat. We have projects in the lung, and we have projects also in the abdomen and the prostate, the urologic system. Many of the projects we use very small tools, try to go through less than 3 millimeter diameter openings so that we can have those invasiveness benefits for the patient. We use a lot of robotics because we're a mechanical engineering lab and robots are a great tool, but we also use every other tool at our disposal as mechanical engineers to be able to make medicine better in whatever way possible. So it's a very problem-driven approach. It's a very operating room-centric approach. It's not like we bring one technology into the operating room and see how many places we can use it. It's more like we're looking at what do doctors need and what do we know as engineers and how do we apply that in some good way for them. Sometimes things come out that you would have never thought of, and this is a simple handheld tool that I would have never thought of without watching surgeries. So we watched a surgery in the sinuses going through the nose, and we saw that most of the surgery was pretty straightforward for the doctor. There were some things we could improve, but something that took them like a half an hour at the end of the surgery was closing up the brain cavity. So they needed to take a little chip of bone and they needed to hold it just in the right spot on the brain, on the bottom of the skull, and then put glue all around it to hold it in place so it could heal. And we thought, well, wouldn't it be nice if they had something that was specifically designed to hold on to that chip of bone? And so we built them this really simple hand tool. That's the kind of thing we look for, is ways that just outside the box you wouldn't have thought of. It's not a complicated robot, it's a super simple tool, something we can write a patent on, something we can then go talk to companies about and try to commercialize. So this is a good example. Somebody wouldn't get a PhD thesis out of this, but it's sure a great side project to learn how does the medical device industry work, how do patents work. Whether you're going to industry or to academia, you're going to need to know these things. And so it's a great example of how students can learn that kind of thing and have a really big impact on medicine.